that we saw in the handout last day, we saw that if I asked you to define energy, energy was technically equal to work done. Right? The more energy you have, the more work you can do. Right? And we basically said that, right? So the more energy a system could do, the more energy a system has, the more work it can do. And we also said that work was equal to, if I gave you an object and I apply a force to that object, and it moved at distance d, right? Then we said that work done was the force multiplied by the distance moved. SI unit, Newton meter, or joules. Okay? And then we listed out all different types of energy. And we focused mainly on two types of energy. We focused on energy due to motion, which we call kinetic energy, written like this, 1/2 mv squared. And then we had energy due to position, right, above the Earth's surface, and we said potential energy was mg. All right. So last day we went through all the different types of energy. Today, I want to take a look at an example, a particular scenario that we have to consider. Right? So let's say we have right? It's Christmas time, right? And we want to eat goat, but this goat doesn't want to be eaten. Goat, like, okay, right? I'll take off the thing. Right? This pig doesn't want to be caught, right? But he reached a cliff, right? On the edge of the cliff here, what type of energy does this pig has? Right? This pig has potential energy, right? Here at the end of the cliff, we have no choice, but he had to jump, right? He had to jump if he wants to escape, right? So the pig will jump all the way down, right? Just before the pig hits the ground, just before he hits the ground, all the pig has is kinetic energy. That's okay. But how come this potential magically became kinetic? Well, if we use the conservation of energy, that says energy is neither created nor destroyed, but is converted from one form to the next. So what this means here is that this potential energy of the pig was converted into kinetic. That's okay. So whenever he lost potential energy, that symbol means change. I'm going to use this symbol. Right? The loss in kinetic energy, the loss in potential energy was equal to the gain in kinetic energy. That's okay? Right. I have a question. At any point in time, you all think these two will be equal? At any point in time on the journey, do you think they'll be equal? Yeah, at some point it should be equal, right? If this is 10 and this turns out to be 10, somewhere in the middle, the potential energy should be equal to the kinetic energy. That's okay? And there's something that have a nice formula that comes out of that, right? But you're okay with the concept here? Right? And what law is this? This law here is the conservation of energy. Right? So when you revise an energy, you should be able to reproduce something like this. Not write back a whole essay, right? You should be able to identify, okay, energy is work done, how to find work, what is kinetic, what is potential, and something like this. Okay? You should be able to identify these things. Right? That's one scenario. What about a very popular scenario, a pendulum? Let's say we have a pendulum moving like that. Right? What type of energy do you think the pendulum mainly has here and here? On the outside. So the pendulum oscillating like this. right? The pendulum oscillating like this. So it reaches its maximum height, comes through here, right? Whatever energy you think it has here and here. Potential. It's now moving. At the highest point here, it's now moving it. And it's above the surface. So therefore, at this point here, it has potential. At this point here, it has. At this point here, it has what? Potential as well. And at this point here, it has connected. It's moving the fastest in the middle. Right? It will oscillate like that. That's okay? So here's an example of the conversion of potential to kinetic, back to potential, back to kinetic. Okay? All right, copy this down. Mass like that, right? Oh, by the way, M is mass and V is velocity, and H is height, right? H is height, and G is gravity. right? Just remember that, right? Just remember that v is velocity and h is the height above, h is the height above the Earth's surface, right? Right, there's one little thing I wanted to show you here. Right, there was one more thing I wanted to show you when potential equal to kinetic. Right, what you see? Potential energy is mass by gravity by height. Kinetic energy is a half mv squared. Right? From this relationship here, I can determine the speed that this pig will be falling at. Right? I can determine the speed that he's going to be falling at. Right? By making v the subject of the formula here. So what shall I gonna do, right? I'm gonna cancel the m's and I'm gonna multiply both sides by 2. So I'll get 2gh is v squared. You see that? Cancel the m's and I multiply both sides by 2 and I get this. Right? Now, if I square root both sides, remember I have this, right? V squared is 2gh. If I square root here and square root here, this becomes v, and this becomes the square root of 2g. Okay? So what this tells me is that as an object falls, I can find its velocity by just knowing the height it's at. Okay? Because remember, g is gravity, we use it of 10. And h is the height above the Earth's surface. That's okay? So this is the relationship allows me to find the speed that the paper will fall at. Okay? So just make a note of this. This is something that we tend to not see at that. Yes. Yes. Right. So Alright, so we're gonna try questions. Number one. Alright, what year it is, the year is, I'll find it. I'm sure what year it is, right? But let's see if we can do the question. Define energy. Right? Define the term energy and state the SI unit, right? What you would say that is Vishish. If you want to define energy, what you would say energy is. Okay, yeah. Or the ability to do work, right? I did a few words, right? To make it sound else one, right? Next one, smart was the SI unit for energy. Energy, joules, right? Good. Write that down. That's part one. That's part one, right? Right? Energy, ability to do work, SI unit. Control Alex. Next part. See if you can identify the type of radiation that have those examples. I'll start with the last one. That's the easiest. What type of energy, what form of energy has objects in motion? Kinetic energy, right? So for the last one is kinetic. So I'll help you with the hardest one. Right? So I'll help you with the hardest one then, kinetic energy. Try the next two. The second one kind of hard. So I'll give that to Annalie. Annalie, radio waves and X-rays. What type of energy is that? Kind of hard, but on the list I gave you. Radio waves and X-rays. Analyze the electromagnetic, correct? Right? That's electromagnetic. Radio wave activity, Reggie. What do you think is important? Look back at the list. Look back at the list and tell me what you think is what type of energy is that? Radioactivity key. What do you think? Oh, you getting any hand up? Right, look at the long list of energy. Oh no, that is summary, the wrong thing. No, let me say it. Alex, Eden, looking like you have it in there. What do you think, Eden? What do you think, Eden? What type of energy is that? Good then, we are full. Oh, rush, Eden. Rush. Any guess either? Huh? Okay. Radioactive decay. All right, husband, what y'all think? Nuclear energy, right? That's nuclear energy. Okay, that happens within the nucleus of atom. Okay, next one. Right, this one might be a little hard to see, but the main energy conversion that takes place when a flashlight is turned on. What's the main energy conversion? What type of energy to what type of energy? Think about it and Jimmy wants to answer. No problem, Jimmy. No problem. Just think about it first. Now those minutes again. 1 minute, 2 minutes, or yeah, what do you think? Jimmy? What type of energy does it have and what is given it? A flashlight here, a battery operated flashlight. Chemical energy in the battery, nice. Okay, giving you electricity, but did that one mean? Light, they're giving you light. They're giving you light and a little bit of heat, right? Okay. I'll also take electrical to light and heat. Right? Because not necessarily you don't have to be a battery operator. Okay. So I'll also take electrical to light and heat. Good. So the main energy conversions is that. Next part. Okay, you might need to write this part, write the values down, right? So what you there? Write down the important info they gave you, right? Right, you don't have to join diagram if you want to get joined. But the important info they give you mass and they give you speed. Mass and speed. You see it? Mass and speed. Why do you want to what do you want to do? Right? With the question, all right. So the question part one, find the maximum kinetic energy. Right? Remember you have the mass and velocity, right? That's right. That's simply right. The mass is equal to 0.5 and the velocity is equal to 1.8. Right? The first value one is the maximum kinetic energy. Right? Online, you'll send the answers, right? Find the maximum kinetic energy. Right? Huh? Good question. 94. Let's move on the same. You don't want that. If you get it right, you get one. If you get it wrong, get 0. All right, online, keep messaging. Right, any more answers? I have 4 answers there. In joules, yes, energy in joules. Right, it should be in joules, right? Nice. Right, remember all those energies are in joules, right? So that would be kinetic energy is what? What's the formula? a half mv squared. Right? So that's a half by the mass. The mass is 0.5 and the velocity is 1.8 squared. How much is that? 0.81. Right? So that's the most amount of energy that this system here could have. Right? That's the most amount of energy it could have. Okay? And remember, in the pendulum, there's a constant interchange of what? Connected to potential, right? The energy out changing. All right. So using the conservation of energy, find the maximum gravitational potential energy. Right? So think about it, and I'm going to ask somebody. Let's have somebody online now. Sorry. Now we ask this next to Rajiv here. Rajiv, what do you think is the gravitational potential energy of the pendulum? Remember, this said to use the conservation of energy, right? Rajiv, what do you think? What's the maximum conversion? Sorry, I mean, what's the maximum potential? Right, very good, Rajiv. And I like the way he said it, right? He said because of the conservation of energy, all of the kinetic will be converted to potential. So the maximum potential energy is 0.81. Right. Now use the math skills. If the largest potential energy is 0.81, find the height. Right? This question I will ask find the height, greatest height. Right? So use the formula, rearrange it properly, let's see what you get. Oh yeah, so you're using something to help you find each. Something that will help you find each. Everybody have it? Have it? Alex, you can one. My next one, so pick my thing in the chat. That's my phone. Right? Help us out, Alexi. What's the formula you use? Right. So you said that potential energy is mass by gravity by height. And height is the potential divided by mass by gravity. Okay? And your potential was what? What you use? 0.81. But what you use as the mass? And gravity is how much you got? 0. Right? 1.6, and don't forget the SI unit, right? Meters. Right? Don't forget the SI unit meters. 0.16 meters. Right? Very good, Nerissa. Very good. Very, very good. Ali, are you getting through? Maria, are you okay? Still, are you paying attention? Are you okay? You got anything? No? Which one? Use this one?
But just make PhD subject instead.
Yeah, but that could work. It didn't work out.
Yeah,
So it'll be v squared divided by 2g.
yeah.
Yeah, it should work. So it'll be 1.8. So some people said this, which is not a bad idea. They use b as the square root of 2gh. If you make h the subject, you'll get b squared and 2g. Right? So that was what b squared is 1.8 squared over 20 by 10. Let's see get the same thing. Yeah, very good. Once there's a conversion of kinetic to potential, you can use that. Okay. Let's go again now. All right. This one, you'll have to take a screenshot of it. Because I can't get it together. Hold on, huh? I'm gonna just clear this screen. Try that in. GG and the bueno. No. Try this one, please. Both hands. Ready? Roll pressure. Yeah. Nice. Yeah. Now logging in. Ready yet? Alex, apa Ah, IB. Oh ya, setelah pagi. Jalan. Boleh shop away. D. Sure. What are the part above D?
No,
IB, okay. Yeah, I think by IB. Yeah, I think I one way half, one way lose, and a way gain. Okay. We check it out that we listen to it. IB belongs to you. IB belongs to you. EBC belongs to Remarks. ABC. 4 belongs to Jamie, and D will pick somebody online. So we pick online. Aiden. Pick Aiden. D is yours. Oh yeah. Huh? Yes. For your online too, so we are picking. Last 2 minutes, huh? Right, let's go. That's correct. Yes. Right. A, B, C. Let's go with Rima. Where's A? Whatever energy it has at A has potential energy. Whatever energy at B. Kinetic. Whatever energy at C. Again. How come? They're not moving under above particular line. Nice. Jamie, part 4. So at another point D is situated midway between A and B. So midway between A and B there, right? Right, now let's zoom in a little bit, right? Right, midway between A and B. If the pendulum is returning to A, returning to A to complete an oscillation, explain what type of energy is increasing. You're returning to A. So what you had before A, whatever energy you had before A, kinetic, okay? So what type of energy increasing? Yeah. So your kinetic energy decreasing and your potential energy increasing. So at E, sorry, at D, the type of energy increasing is your potential energy, right? And the reason is the object is slowing down and going to maximum height. Which one? Loss in kinetic? Yeah, loss in potential. Sorry, loss in kinetic is gain in potential. Yeah, that can work as well. Loss in kinetic is gain in gain in potential. The other way around. That can also work, right? Huh? Nah, not increasing. Potential is increasing. Right? So your potential energy increasing because based on the conservation of energy, the loss in kinetic is the gain in potential. All right, nice. Everybody got our online? Rajiv, are you okay there? Serena? Yeah, you're okay. Right, last part, Eden. As it just struck me there, I'll forget you. Right? The last part, Eden, has to do with calculate kinetic energy. Real basic stuff. What's the formula for kinetic energy? A half mv squared. So we know what half is. What's the mass of the object? 0.4. And what's the velocity? 5. Nice. Do you think I'm going to get? Huh? 5 joules? Very good. I'll do catch it. Right, very good. You did? Yeah, you can put anything. I'll make that one better. Hi, online, you're okay there? Wine pick on you. Solario, come here and listen. Miriam, you okay? Right, nice. That's the first slightly other one now. That was 2 Oh Lord, what is this? What? All right, last one. Last one, then again, 2. Huh? Yeah? Give me a short clue. Right up. Right up. The 2 cell?
Yeah.
Okay, yeah. Very good. One to the last. You're right, I'm right. Exactly.
Not all.
So stand like I'm right. Huh? I might have the right stuff. You don't have all it.
Sorry. And these are the show and some way can sit and look and go on the back. I think it's when I leave.
What looking? You want me to read all that? Then I get from ChatGPT? Are you sure they're from ChatGPT? And I'll tell them what to do. And we tell me how long they're I'm not gonna do that. But it comes from ChatGPT, so it's right. I didn't have to read it. When I was checking, she didn't read like ChatGPT. And it's getting up chat there, we. Oh yeah, last one. Last one here, and then we'll do a thing, right? When school we open, we have to do pressure. And then we don't go to the mechanics. Because I know where it comes from, why we just have to go, I want you to grab my things. But no, no. I'll give it a graph, but we'll tell you what's going on.
I think you take a picture and see what I tell them this what the scale to.
Yes, you get that, do it. You know what you well, or?
I didn't do it.
Like when I go in that
I love
exam.
it for premium. Oh, and you have 3 pictures, fire me.
I don't feel my living. Adreno.
It was one of those, it was, I got blown away.
Oh yeah, last question online. Some of you are not sending any answers, eh? I need some answers from Mariam. You do your work. Who is that man? Arissa. Arissa, you good. Send your answers, right? Serena. And Mr. Salario. Send your answers, please. Last question. Energy to do it. So therefore, I think energy. You gotta get your work done. I giving your work done. You got it. You mind in my questions?
Yeah. I knew it. I was just.
For what? Finish already? Gabi? Double. Double? Which one? Right, clearly, that's the different kind to do it done. That'll get them a little, that'll get them a little more. Of mine was kicked. So when hit the ground. So yeah, it's just two main things I look at, yeah. So when you hit it, have nothing. Have no energy, it's on the ground. But from when you hit it, there's a gain in kinetic. And that kinetic is converted to potential. And then when it reaches top, potential is converted into potential converted back into kinetic as it was. Yeah. Yeah, just a formula. Part two, just a formula. So when you kick the ball, it gains kinetic, right? That gaining kinetic, right, allows it to start and move upwards. That kinetic is lost and it gains potential, right? And then that potential is lost to gain kinetic as it falls, right? Always make a note as a byproduct, you will get sound and heat. Right? You might feel it on the ball, but the ball gets hotter. Okay? So it's kinetic to potential back to kinetic. Part two is just a formula. Huh? Yeah. Potential to kinetic, and then tell them that heat and sound is also produced.
Potential energy.
Now, if you see it on the ground, we don't really have anything. Right, but the question said from when it was kicked. So it's after it connects, after it kick it, right? So when it kick it, it's kinetic to potential to kinetic. And there's also a production of heat and sound. Right, write the formula in part two and then go to part three and you're done. And I'll give you a clues, right? When you go back on Kahoot, right? Just check and see if you'll get reward, right? And if you come to it, right? When they go back, see if you get any rewards. And let's see what happens. Huh? Let's wrap up, right? Part two, determine an expression for potential minus kinetic. Right? That's all, no calculation, right? During a game, if you have mass over the head, if the velocity is 7, calculating momentum. How do we find momentum again? Mass by velocity. That's all. What's that? Right, number one. Take 3.01. That's all, right? We don't need the heights. Will you give it up? All right. All right, last thing, now who can be done? Right? Jogging paper. All right, join the Kahoot, please. Anybody else again? Alright, let's go. Ready? Those two blind come close, right? So I can see. Right, you see that card, it comes pencil. Now look. Just some people. And a G cannot create. No, I hate some people there. I want to talk should be where it starts, right? Up. Four grams left. Those grams. Right, you have to work in kilograms, right? When you catch there, they work in grams. Right, you have to work in kilograms. Right, you have to work in kilograms, right? That's you and I think. Problem. Right, so you had to use 100 as the energy, as mass by gravity by time, and then solve each. And you will get solve each, right? Next one. What happened? I didn't clear. Right, last one. Lexi and Rajiva and Serena close to one. And a little everybody kind of close. Double points here. Double points slide to the right answer. I like this one. Calculate. That's a really good.
That got only. To the right. So it's like only with.
I don't know. I don't know what it is. I don't know why I do that.
I think this is the most significant.
I did it. And people come to Serena, well done. Steve, well done. Well done, Rajiv. Fourth is Aliyah, fifth is Ruhu, number 5. Nice. And
I think it's
who winning holiday? And up his scores and tell you on the group who win, right? Who win the holiday? Whenever you take part here. Alex, so don't Alex, this one? This one? Come last, so you took Alright, nice. Alright, so that is the end of, you still have one thing to do, power, right? Just read up on what is power. Alright, so that's it there for today. Alright, so next day we continue with